so I don't lose them. I want to introduce you with a short bio. Yes, okay. Yes, yes. Let's see. Yes, oh, you have a very good. Yeah, so infrastructure safety is this beginning part, maybe. Yes, yes. Okay, okay, excellent. You have 20 minutes. Because we have 2 hours and 6 presenters, including questions. Yeah, so 15 minutes. Yes, yes, yes. Yes, I think so. I'm going to do that and call. Yes, okay. Yeah, yeah, yeah. That's a better. Okay, I guess we'll get started now. I want to thank you for coming and welcome you to our parallel session, Innovation in Road Technologies. I'm Andrew Crow, and I'll be your moderator. This is a two-part session. The first part will be road maintenance examples of innovations, where we have 4 presentations, and then the second part will be new functionalities for roads, where we have 2 presentations. I would like to begin by welcoming our first speaker, Luc Rens, from the European Concrete Paving Association in Belgium. He's a civil engineer from the Polytechnic Division of the Royal Military Academy in Brussels. He is an expert in concrete pavements, safety barriers, and all other applications of cement and concrete in road construction. Since 2009, he has been the managing director of EU Pave and a member of the Technical Committee, Environmental Considerations in Road Projects and Operations of the World Road Organization, PRC, a member of the working groups within the European Union Road Federation, and numerous other board positions. So we want to welcome Mr. Rens as he presents innovative techniques for the repair and maintenance of concrete roads.
Thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. We just had the pleasure to taste one of the local products of France, the good red or white wine. I'm going to talk to you about another quality local product, the concrete, although I have to admit that the wine has been better developed in France. When the roads, so I'm going to talk about long life pavement circular economy, but then mainly about the available maintenance and repair techniques, a case study on cross-stitching of a longitudinal joint, and to end with some surface treatments. Road pavements are designed to withstand the traffic over a predicted design lifetime. However, sometimes there is a wrong estimation of that traffic, and even long before that design lifetime, which for concrete roads is about 30 to 40 years, sometimes long before the design lifetime has been reached, the traffic has already gone over it. Or sometimes, as simple as it is, the concrete road is still there after many years after this design lifetime, and it has to outperform this projected service life, often requiring a minimal maintenance. You see on the picture an example of a rural road in Belgium. Most of the examples I give are from Belgium. It's just my home country because I am also a consulting engineer for the Belgian Cement Association. And as you can see, this is a road built in 38, and let's say in 2 months it will celebrate its 80th birthday. If we consider the waste hierarchy from the European Commission, which is first prevention, then reuse, recycling, recovery, disposal, well, concrete pavements are in the upper level of this hierarchy. Just because of this long lifetime, durability is extending the lifetime. It's also prevention of reconstruction, in this case, prevention of waste. Obviously, there is also the possibility of reuse and especially recycling. The concrete is 100% recyclable. With a few other examples, another local road from 1938 and the motorway, one of the motorways in Belgium in continuously reinforced concrete, built in 71, of which a big part is still in service, at some places covered with an asphalt layer, mainly for reasons of comfort. Because obviously, yes, those old concrete roads, older than 30, 40, 50 and more years, have been designed according to old concepts, according to other criteria than the one we use today, and sometimes all with older construction equipment. For instance, noise was not a big issue 30, 40 years ago, while it is now. It means that a lot of those old concrete pavements do not longer satisfy the criteria which we put today to modern roads. However, if we build today new concrete pavements, then quality surfaces are possible thanks to modern adapted design, the use of dowels, also, for instance, the use of continuously reinforced concrete. Also new construction techniques, modern equipment, and new surface finishing methods. But those old pavements are still there. So now, what can we do to turn those old pavements into better and quality roads? How can we make them meet those functional requirements? Smoothness, the evenness of the surface is of a big importance, especially for the road users. That is what is important for them. Also, the safety, which is given by the skid resistance, so by the appropriate texture of the surface. And as I already mentioned, today, the traffic noise, and so particularly the rolling noise is important. So it is due to the tire-pavement interaction. As you can see on the pictures on the right, you see the example of the use of a two-layered exposed aggregate concrete, which is used mainly in Austria and Germany, also in Belgium, in order to produce low-noise surfaces. And finally, what is also important for the road user is the fact that they can use the road, so that it is available thanks to a minimum maintenance delay. So minimizing the need for maintenance, and if there is maintenance, minimizing the time that is required. So here you can see an overview of a whole set of ranges for repair, maintenance, preservation of concrete pavements, starting with the repairs, a fast-track full-depth repair using rapid hardening concrete mixes, sometimes a partial depth repair with epoxy or polymer-modified cement mortars. The basic maintenance of concrete roads, which is the joint and crack resealing, and even that is often forgotten. Slab lifting or stabilization by grouting. Load transfer restoration through dowel bar retrofit. Cross stitching of a longitudinal crack or joint. And finally, the surface treatments. I'll come back to those later on. I'm not going to go deep into detail for all of those techniques. I'm just going to pick out a few of them, starting with the full depth repairs. Let's say the important message is forget what people always think, that the concrete needs 28 days to harden before the traffic can drive over it. No, even with a normal, let's say the normal, good quality concrete mix that we use, even after 4 to 7 days, the road can be reopened to traffic. When it has to go faster, using normal materials, the normal types of cement which are available, it is possible to reduce that time to 2 or 3 days. Well, often the challenge is not getting the strength, but it is the maintaining of the workability. If it has to go faster, and sometimes, no, first I'm going to show you this. It is a follow-up of this graph, shows you the follow-up of the temperature in the concrete. There is a relationship between temperature and strength, and you see here the strength that was obtained after 30 hours of hardening, and we got to something like 43 megapascal. Those were the values in small slabs on insulated and non-insulated, and we see that the real pavement is just in between. So this type of measurements allow us to predict the concrete strength. And now, thanks to the maturity concept, now special sensors have been designed in order to follow the temperature evolution and to predict the strength at a given moment. When it has to go faster, for instance, on airfields, where sometimes there is only a very short window of 6 or 8 hours available to do the whole repair, then you need very special types of cement, no longer the traditional ones. You see here it's the conventional early strength concrete in blue, while you see the rapid hardening concrete, one of the different types which are available, where you see that the strength development goes much faster, and that in one day, or even, as I said, in 6 hours, you need to achieve the strength necessary to reopen for use. Dowels are the smooth steel bars which are used in concrete slabs in order to guarantee the load transfer between the slabs. They also guarantee the driving comfort. Well, for those older pavements, sometimes slabs were not used during construction. It is still possible to insert the dowels when the road is already there. And I give you here a very short case study of a regional road, N44 in Belgium, which was built in 1958. Slabs were quite thick, about something between 25 and 30 centimeters thick. They were long, and as you can see on the two middle pictures, there is quite some heavy traffic on this road, but still those slabs were in very good condition. So only a very limited number of slabs were cracked. But as you can see, those expansion joints that were used between those long slabs, they are widely opened, and they create problems in terms of comfort and problems of vibrations. So this was a good case to test the dowel bar retrofit, where you can see that they cut slots in the concrete pavements, and they insert the dowels manually, and the slots are filled again with a polymer modified cement mortar. As you can see on the picture on right bottom, we use 2 times 3 dowels, so exactly located in the wheel tracks. It was very effective. So the let's say the problems of all vibrations were solved at that moment. Another case study on another regional road, the N49. It was a continuously reinforced concrete pavement, and it was not an old one. No, this one was built only in 2005, 2006, and yet there was a problem of opening of the longitudinal joint, and the causes of that issue were the use of wrong material. Let's say even the prescriptions were not correct. Smooth bars were allowed instead of the ripped bars, and also the wrong installation method. The tie bars were bended beyond the yield strength and elongated. So cross-stitching is a solution. Cross-stitching is inserting tie bars under an angle, oblique, and first they clean the jointing, fill it up with polyurethane foam, and they drill the hose. The foam is needed to prevent the glue to come out through the joint, and then the glue is inserted, and the tie bars are fixed and are tested afterwards, and that was successfully. There was another problem. It was the fact that the joint was widely opened and had not always the same opening, so we had to use preformed joints of variable width to reseal that existing longitudinal joint. So you see, there is a solution for each problem. Let me end with the surface treatments. First, you have the micro milling or fine milling. It's a similar equipment as for asphalt, but with a larger number of cutting tools, so that's why you get a real fine texture, and it's very often applied on the local road network. Very recently in the village where I live, all the old concrete pavements have been treated in this way, and I can assure you that there was a significant improvement. And interesting for the authorities is that this can be done at a relatively low cost. Obviously, it has to be combined also with renewal of the joint sealant. A better solution is a diamond grinding. I'm not going too much in detail because my colleague, the next speaker, will go more into detail about the surface finishing techniques. It was a long time a restoration technique known as bump cutting for restoring the evenness after a failed construction, but now it is a good alternative also for surface finishing. And with this diamond grinding, the evenness is significantly improved and skid resistance is also maintained or even improved. You see here also an example of a rural road. To come to this, what our colleagues from the US call the next generation concrete surface, and also my colleague Mr. Roberts will go further into detail. So I will only show one European trial. There were also trials in Germany and the Netherlands on newly built concrete surfaces. In Belgium, we did it on an old one, so it was a good restoration. The road consisted of concrete slabs, 35 years old, a very rough surface. As you can see, also steps faulting of the joints. And we used two different configurations of this combination of grinding and grooving, always in the longitudinal direction. And so the grooves are 4 millimeter deep, the grinding is 1 millimeter deep, and you can see the difference between the two configurations was the spacer. In the first one, 1.5 millimeter, in the second one, 3. Let's go immediately to the results. So yeah, on the right you see the nice picture of this type of finished surface, and you can see that we had a reduction of noise of up to 6 decibels with CPX measurements. There were also later, after 11 and 15 months, the measurements showed an increase and then a stable level of the noise. So it's still a reduction of 4 decibels, which is still spectacular. Also for the statistical pass-by measurements, which is at a point at the side of the road, we saw the same result, initial reduction up to 6.7 dBA. And also for the heavy goods vehicles, there the reduction was somehow lower, up to 4 dBA with statistical pass-by measurements of the traffic noise. So I think that this next generation concrete surface is a very promising technique and should be applied more in the future to become my generation concrete surface. So to end, I would like to tell you that all the techniques which are necessary to turn old concrete roads into high quality, smooth, comfortable, new, modern pavements, they are available and they should be used. It's still necessary to share this know-how and experience, and therefore I mention the addition of a brand new manual edited by SPECBEA, which is the French Contractors Association of contractors dealing with concrete pavements. It's a very nice, a very well written manual on the maintenance of concrete pavements. I also would like to thank the organization of PPRS to give us the floor to talk to you about the concrete pavements. Ladies and gentlemen, I thank you for your kind attention.
Okay. And thank you, Mr. Rens.
Maybe just one word. For more sharing of information and knowledge, I will invite you to the 13th International Symposium on Concrete Roads, organized in Berlin later this year in June.
Okay, very
Thank
good.
you.
And do we have any questions? I think we have a minute for questions. Okay, with that, thank you, Mr. Rens.
Thank you.
Okay, next up we have John Roberts.